Right, now we're going to do an exercise that's going to make use of what we've learned about pure substances. So let's start out with our given information here. So I've got given, I know that my tank volume is 5 cubic meters. And what else does it tell us? It says this particular volume of stuff is a saturated mixture. So that means we're going to be under the dome. We'll take a look at that from the tables in just a second. And we've got a pressure of 50 kilopascals. And then it says the saturated liquid occupies 1%. Volume of the tank, determine the quality of the mixture. So remember, quality was X. So I'm just going to come down here and write find X. And then we also want to find the total mass of the water in the tank. The mass total. And we'll see if we can figure that out. All right, so let's get started on this. So our first step is to see what we have here. So we've got this, and let me use my F for fluid or liquid. So it says, okay, we've got this liquid occupies 1%. So let's say there's our liquid, and I'm going to say something like 1% of that volume is occupied by our liquid. So if we think about our total volume is both our liquid and our vapor mixture here, we're going to start going to town here and trying to find our totals and our gas. Okay, let's see if we can figure this out. So I'm going to rewrite this. I'm going to say, well, I'm going to look at this VG. I'm going to say V total, so my volume, minus my fluid. And what I'm actually thinking about is I'm thinking for my quality, remember that quality is mass of what's going on with the vapor, so the mass of the vapor, and mass total, so mass of the vapor over mass of all the stuff in there, my fluid and my vapor. And some other notes here. So I know that if I'm going to go back to my tables, look in the back of my book at those tables, one of the properties that I'm going to find is specific volume. So remember that specific volume is my volume over my mass. So what that means is that for my water, my saturated water, so saturated liquid, I should say, not saturated water, saturated liquid. We have two saturated states, right? I have my saturated liquid, saturated gas. Those respective volumes look something like this. And we're going to poke in the back to those tables. Let me bring those tables up. Here are my tables. So I'm in A4, which tells me temperature, and let's see what we have. So we've got this in terms of pressure. So I don't want to look at this in terms of temperature. Let's scroll down, scrolling. Let's look at it in terms of pressure. So we're looking at 50 kilopascals. So let's go down here. So make sure that our units match up, kilopascals, 50. There we are. So I'm looking right here. And now across the top, I see that I've got a whole bunch of information. I've got that specific volume for my vapor and specific volume for my liquid. So liquid and vapor saturation, either extreme. So let me pluck that information off and use it. All right, and I'll record that right here at the top. So my saturated liquid is 0.001030, and let's go ahead and put the units on that as well. It should be in meters cubed per kilogram. And then we've got 3.2403 meters cubed per kilogram. So we can start plugging in stuff. So let's do that. And just going to make a notation here, make sure that we see that this is total. So I'm going to plug in 5 cubic meters here minus my fluid, so 5 cubic meters times 0.01 give me 4.95 cubic meters, so mostly gas. And now I can use my two formulas over here to find mass. So mass, that fluid is going to be our volume over specific volume, so what we have up top there, and my mass of the gas slash vapor is volume, that vapor, over specific volume. And I'm just going to chaotically draw that in here. So we've got F goes there, got the G term. Oops, I'm sorry, doesn't quite go there. Goes downstairs, right? There and there. And we're going to punch those numbers in. I'll plug those into my calculator for my fluid. I end up with 48.54 kilograms. And for my gas, I end up with 1.5276 grams. When I add those two together, I get my total mass, which ends up being 50.07 kilograms. All right, so I'm almost there. I've got my total mass. That's good. Now I just need my quality X. So I'm going to take my masses, plug them back up here into my equation, and I end up with 0.031. Okay, so just looking at this, we see that fluid is a heavy contributor to the mass, right? So we're pretty hefty mass-wise of the fluid versus mass of our vapor. And if we're looking at the quality there of the mixture, we're still a long ways off from being completely to the other side of that dome, right? So remember that when we get to an X of 1, that means our vapor up here is at 100%. So right now we've got about 3% of our total mass being consumed with the vapor, which makes sense. We're looking here at this right here, and we say double that takes us to 100, so that's about 3. Yeah, so about 3%. So that kind of jives. All right, hopefully that was helpful.